Hi, this is Alex from devstories.eu. Shapely, episode 6 of 8. A simple mathematical point has exactly zero area. It is just a location. But what if you need to represent a blast radius around that location? You can instantly transform that zero-dimensional point into a massive, precise polygon. This is the power of constructive operations, specifically buffers and hulls. Constructive operations take an existing geometry and build a new, different geometry out of it based on its spatial properties. You can think of them as safety wrappers around your spatial data. The most widely used constructive operation is the buffer. You pass a distance value to the buffer function, and Shapely returns a polygon representing all points within that exact distance from your original geometry. If you have a line representing the path of a chemical spill along a highway and you need to establish a 50-meter safety zone, you call buffer on that line geometry with a distance of 50. The output is a new polygon that traces the entire route, expanding outward exactly 50 meters in every direction. Here is the key insight. Buffers do not just grow, they can also shrink. If you pass a positive distance, the geometry inflates. If you apply a negative distance to a polygon, the geometry deflates. A negative buffer pulls the boundaries inward. This is incredibly useful for finding the safe inner core of a zone, isolating the area that is a strict distance away from the dangerous edges. Sometimes you do not need an exact buffer around complex shapes. You just need the absolute limits of your data. Calling the envelope property gives you exactly that. It returns the bounding box, which is the smallest perfectly upright rectangle that completely encloses your geometry. It is mathematically cheap to calculate and perfect for fast spatial indexing. But what happens when your data is not a solid shape, but a scattered collection of points? If you have dozens of contaminated soil samples and you need to draw a single continuous boundary around the affected area, you need a hull. Shapely gives you two main ways to do this. The convex hull calculates the smallest convex polygon that contains all your geometries. You can picture this as stretching a rubber band around a board full of pegs. The rubber band snaps tight across the outermost pegs. Because it is convex, the boundary never dents inward. There are no interior angles greater than 180 degrees. While the convex hull is reliable, it often includes a large amount of empty space if your points form a crescent or an irregular cluster. If you need a tighter fit, you use a concave hull. Instead of a rigid rubber band, a concave hull acts like shrink wrap. It allows the boundary to cave inward to follow the actual footprint of your data. You control how tightly it wraps by adjusting a parameter that limits the maximum allowed length of the boundary edges. Tighter limits force the boundary to fold into the gaps between points, giving you a highly accurate, realistic map of that contaminated soil. The difference between these tools comes down to how closely they hug your data. The envelope gives you a quick, loose box. The convex hull stretches tightly across the extreme outer points. The concave hull shrink wraps the exact shape, and the buffer strictly pods the edges by a defined distance. If you want to help keep these episodes coming, you can support the show by searching for Dev Stories EU on Patreon. That's all for this one. Thanks for listening, and keep building.